Hi coders, let's build a mobile game.
Don't get any closer to that gas giant. Something is stirring in the upper atmosphere.
First, we will write all the game logic and implement all the main features. You can reuse that boilerplate later for many different touch-based full-screen games. And then we add graphics, animations and sounds, turning it into a cartoon space horror game. I want you to build projects you can be proud about and you can show to your friends. This one will be a full-screen game with touch events, fully playable on any device, from a big horizontal computer screen to a small vertical mobile phone. So you can carry it around with you if you want to show everyone what you learned and what you can do with JavaScript.
Our presence triggered a feeding frenzy. They seem to be attracted to the life signs of our non-mechanical crew members. Immediate retreat advised.
You can click the like and leave a quick comment below if you want to support my work.
Endemic to the supercritical fluid layers of this distant gas giant, this creature lives in an extreme pressure. They can phase through solid obstacles. We need to hit them when they're in their solid state, so time your attacks carefully.
I want to show you how to use state design pattern to give our creatures different states. We will implement a special enemy type that can only be hit when it's in its basic flying state. If we hit it while it's phased into a different dimension, we will give it a speed boost instead, and it might cause one of our unique randomized crew members to get eaten. In the extended class, I also went back to Planet Defense and Space Invaders game, and I added a bonus lesson to each project, implementing this new phase-in, dimension-shifting alien in both of these games. Have fun! You can download 2 background images in the resources section below. I take the horizontal background and I set it as background URL here. Background size is cover, which will scale the image to the smallest possible size that still completely covers the width and height, leaving no empty space. I create a div with a class of controls. We will have a full screen button and a reset button. We will also control full screen and reset with keyboard, but we will need these buttons for mobile devices. I will give these buttons width and height, black background, and white text. If you want, you can also use a custom font. For example, I can go here to Google Fonts and I search for a font called Bangers. I select the font here and it gives me links that need to be included in index.html, ideally up here before I include style CSS. Like this. Now I can use bangers all over my codebase. For example here for font on the buttons. I also give them a white border. We will write all the logic here with JavaScript in main.js file. Maybe I will split this into multiple files later. Here we can define our classes, but we make sure we only instantiate them after load event has fired, after all the resources are loaded and available. All the style sheets, scripts, HTML elements, images, and so on. Once the page has loaded and we know HTML Canvas element is available, we can set our project up. I point JavaScript towards my Canvas element using getElementById. I define CTX that will store an instance of built-in Canvas 2D API. I set Canvas width and height to cover the entire browser window. In style CSS, I set background position to center to make sure the planet is always in the middle on any screen size. I position the controls, left bottom, like this. I can also organize the buttons vertically using Flexbox. Transparent background and no border on controls here. Margin on buttons 5 pixels. I can give it box shadow and text shadow, for example. Transition 0.3 seconds. And on hover, active and focus, we animate box shadow and text shadow, and also the button background. Game class will be the main brain of the codebase. It will manage the state of our project. It will expect canvas as an argument. Inside, we convert it to a class property, and from there we extract width and height. Because I want to make sure that width and height of the game is always the same as the width and height of canvas. We give it a custom resize method. It will expect width and height as arguments, and we will resize canvas element to these new values. And it will also set the width and height properties from lines 8 and 9 to these new values. I create an instance of my game class. It expects canvas, so I pass it canvas variable from line 20. When we create an instance of a class, all the code inside a class constructor is automatically executed line by line. I can take advantage of that, and I can put my code in here that I want to run at the point when an instance of this game class is created using the new keyword. I can even put event listeners here. We will listen for resize event. The only problem is that the event listener is on the window object, and I'm placing it lexically inside my game class. If I want to access this keyword from inside this callback, it will refer to the window object. For that reason, when I try to resize my browser window and built-in resize event triggers, using this.resize here will result in an error. Game object is not visible from inside here. We need this keyword in here to point towards the game object to allow us access to properties and methods that sit on the game class, including our custom resize method. I can do that by using ES6 arrow functions here instead of a regular callback function. One special feature of arrow functions is that they inherit this from the parent scope. Now, using this dot here will point towards the game object, which is exactly what we need. Now, when resize event triggers, we are setting width and height of canvas and game to 150 times 150 pixels. If I console log the auto-generated event object itself, I can explore it. This object gives us all kinds of information about the event that happened, in this case the resize event. For example, here inside target we can find inner width and inner height properties, which will give us the new dimensions we resized to. I can take these values and resize my canvas and game to these new values. Now, when we create an instance of game class on line 29, all the code inside the constructor is executed, and resize event listener is automatically applied. Now I can resize my browser, and canvas will also cover the entire available browser area. We can also click down here to emulate mobile devices. It is not always 100% accurate compared to testing your code on that device natively, but it is close enough to get started. This is Google Chrome browser, by the way. It might look different for you if you are using a different browser. I recommend using Google Chrome for this course. I can now select different devices from this drop-down, and I can see what the game will look like. Sometimes the preview glitches out when we swap between devices, so I need to manually refresh the page. This doesn't really matter because in the real world, no one will be swapping between iPhone and Samsung phone without reloading the page. And reloading the page always fixes the positioning problems if they come up. You can see that our simple prototype works relatively well already. Let's keep working on this. I can also create a media query for small screen sizes. I will assume this is a mobile phone, and in that case I will use a different background image that is more vertical, suitable for vertical mobile screens. I'm giving you both of these high-resolution images in the resources section below. You can also crop this image and use it for other projects if you want. Now we have a very simple, responsive game world that works on wide horizontal screens as well as on tall vertical screens. Perfect! To keep this codebase easier to navigate in, I will create another JavaScript file called enemy.js. Here we will have our enemy class and we will extend it into multiple enemy types. I could use JavaScript modules here, but then I would have to show you how to run a local server. So I will keep this simple and I will just include enemy.js file here like this. It needs to come before main.js when we do it this way. The order in which we include individual JavaScript files can be important. I can cut enemy class from main.js and I paste it here inside enemy.js. Enemy will expect a reference pointing to the main game object as an argument, and inside we convert it to a class property. Through this reference, we will be able to see and access all the properties and methods on the main game class. Each enemy will need x and y coordinates so that JavaScript knows where on canvas to draw it. It needs speed x and speed y, and width and height. I will set it to 50-50 initially. Custom draw method will draw the enemy on screen. Game will have a render method that will draw all enemies as well as all other game objects. As we build our project up, it's good to test it step by step so we catch any potential errors. At first, render will expect context as an argument, and from there we will call built-in fill rectangle method to draw a simple rectangular shape. I call this render method using the game variable from line 28. It expects context, so I pass it ctx from line 24. The default fill style, if we don't override it, is black. We are drawing a black rectangle at these x and y coordinates with this width and height. I can set fill style to a different color here, for example green. We are building a game and things will be moving around. We achieve that by drawing, updating and redrawing the objects over and over to create an illusion of movement. Custom method I call, for example, animate. I will call game.render from inside, and I call built-in request animation frame method. It sits on the window object, but we don't need this part. JavaScript will know where to find that method automatically. I pass it animate and I call it here to start animating. We are already animating. I can prove it by creating position x property. Using it here as x position on the rectangle, and I increase position x by 1 for each animation frame. We see old paint, so I can also clear canvas from the old paint between every animation frame using built-in clear rectangle method. Now we have a moving green rectangle we are animating. I can delete this. When I resize browser window, resize event listener will trigger our custom resize method, which sets canvas to the new width and height. As a side effect, when we resize canvas, it sets canvas state to default. All the properties will be reset, including fill style, which will be reset back to the default black color. For that reason, when we resize, we need to redeclare these styles. One way to solve this is to make sure we have access to this ctx variable from inside our custom resize method to make sure the green fill style applies even after resize. I can pass ctx from line 24 to game class constructor as the second argument here. Up here I make sure it is expected. I convert it to a class property. Now I can call built-in canvas drawing methods and properties from this.ctx while inside the game class. This line gets overwritten when resize method fires, so instead I will set fill style to green here after we resized. I will give our game a custom start method that will run just once when the game starts or when it restarts, and it will set everything up. At first, I just call resize to make sure the green fill style applies when the game loads. It expects width and height as arguments, so initially I pass it window in width and window in height. Same as we are automatically applying the event listener here, we will also automatically trigger this.start when an instance of the game object is created using the new keyword here. Now the color we give to fill style will stay even as we resize the browser window. Perfect. Now I can take this.game.ctx from here, access through this property, and I call fill rectangle representing the enemy. So we pass it x, y, width and height of the enemy object. I can also give the enemy a different fill style here. We need to give it some x and y coordinates. Here I'm including enemy.js before main.js, so enemy class should be available from inside the game class here. I create a property called this.enemy1 and I set it to an instance of our custom enemy class. It expects game as an argument here, so here we are inside that game object, so I pass it this keyword, through which enemy object will have access to all properties and methods on the game class. From render, I want to call draw method we just defined on enemy class. So I say this.enemy1 from line 7 dot draw from line 11 here. Nice, we are drawing an enemy, and this confirms we have successfully established a two-way connection between game and enemy classes. Nice work. This render method is called over and over for each animation frame here. We are just redrawing the same red enemy at the same position, but we can also move it around by calling its update method. It doesn't exist yet, so I define it here. For each animation frame, I want to increase horizontal position of the enemy by speed x and vertical position by speed y. Plus 1 pixel on the vertical y-axis will result in movement from top to bottom. I can also say if enemy moved all the way to the bottom, set its vertical position back to the top. I make it move faster. I can also randomize the initial horizontal x position, and I also randomize it every time we reset. I can create multiple enemies like this. You don't have to do this part. I'm just showing you a very inefficient way how to do this. It could work if we have just one or two objects, maybe, but in this game I want to have tens or maybe even hundreds of enemies. I can randomize speed y to make them move at different speeds. And if I randomize this.y on the first load, they will start from a different vertical position. I can make them reset all the way behind the top edge, so they slide in from the outside of canvas area. We know that everything works, and we have an enemy class that can be instantiated multiple times to create a swarm of enemies. I delete all of this because there is a better way to structure this code. I'm going to turn each enemy object into a reusable object pool member. It means that we will take it from the object pool and activate it when we need it, and when we are done with it, we will just return it to the object pool rather than deleting it, and we will reset its properties. Reusing our objects using object pool design pattern like this can massively improve performance of our code bases because we avoid issues related to automated memory allocation and garbage collection processes that run automatically when we create and destroy many objects in a code base. We will reuse our enemy objects over and over, save in memory. Every object pool member needs to have a property that indicates if it's currently active or inactive. I will call it this.free, and if the object is free, it is inactive, waiting in the object pool to be used. If free is false, it means the object is currently active in the game. It is being drawn and animated, and it is not free. It is not available to be taken from the pool. Each object pool member needs two helper methods. Start method that will run when we activate it. Inside we set free to false. And reset method that will run when we are done with the object. For example, when enemy gets destroyed, reset method will set free property back to true, returning the enemy into a pool of free and available objects. We will only update and draw the active enemies. We will run update and draw methods only if this.free property is false. So enemy is an object pool member. It has a property that indicates if it's free or if it's currently being used. It has a method to activate it and a method to deactivate it. Update and draw methods only run their code for active objects. When the enemy moves off screen, we call reset method to deactivate the enemy and return it back to the object pool. Some properties on the enemy object, for example the x and y coordinates, need to be reset every time the enemy object goes through its life cycle. We can reset them at the point where we take the object from the pool or at the point when we return it back to the pool. I will choose to reset the properties inside the start method. We will randomize the enemy horizontally and we will set it just behind the top edge of canvas vertically. So this is how you turn a regular object into an object pool member. The second part to this would be managing the object pool itself. We will do it from our state management class. Enemy pool will be an array that holds all active and inactive enemy objects. We need to choose how many enemies we create. This number will be static. It needs to be high enough so we don't run out, but also not too high because we would be wasting memory. We can adjust it later when the game is playable. 50 seems like a reasonable number. Game class will need two helper methods to manage the object pool. A method to fill the pool with 50 enemy objects. We will run a for loop. Each time it runs, it takes enemy pool array and it will push new enemy in there. It expects game as an argument, so I pass it this keyword here. We did that before. I want to call createEnemyPool automatically when we create an instance of game class. I will console log that enemy pool after we created it. I need to use this dot here. In console, I can see we have an array of 50 enemy objects. I open one to check we don't see any undefined or null values, which could indicate a problem. Now I want to periodically activate a new enemy, let's say every 1 second, every 1000 milliseconds. We are using request animation frame, which is automatically generating timestamps for us. Let's use them. I will create a helper variable I call last time. Here we will hold the timestamp from the previous animation loop. The request animation frame method is auto-generating timestamps. All I have to do to access them is to assign them a variable name here. It will know that we want that timestamp value if we do this. For every animation frame, I want to calculate delta time, which is the difference in milliseconds between the timestamp from this animation loop and the timestamp from the previous animation loop. After we calculated delta time, we will set last time to the current timestamp so that it can be used as the old timestamp in the next animation loop. Delta time tells us how many milliseconds it took our computer to generate one animation frame. Then we can pass that delta time value to render, where we will write some simple logic that will accumulate these small millisecond values until a certain breakpoint is reached, and then we can trigger an event. Request animation frame automatically adjusts the speed at which it serves the next animation frame to the screen refresh rate, because it would be a waste to calculate positions for frames that your monitor or your phone screen is not able to display. In most cases, that would be 60 frames per second. In render, I make sure delta time is expected and I console log it. 1000 milliseconds divided by 60 frames per second is around 16.6. It takes my computer around 16.6 milliseconds to calculate and redraw each animation frame. Perfect. As the code runs, we are generating timestamps, calculating delta time, and passing that to render method. From there, we can make this value available all over our codebase to create any kind of periodically repeating event. Let me show you how. It's easy. We will need two helper variables, enemy timer and enemy interval. Enemy timer will accumulate delta time from 0 to 1000. Then it will activate one enemy and it will start counting again. We need one more helper method that, when called, will search enemy pool for a free and available enemy object and it will give it to us. Inside we run a for loop over enemy pool. As soon as we find the first object in the pool with free property set to true, the first inactive object, we will return that object. I can put that logic that activates new enemy every 1000 milliseconds directly into the render method, but to keep the code a bit cleaner, I will write it in a separate method. Handle enemies will expect delta time as an argument. If enemy timer is less than enemy interval, enemy timer starts from 0 and enemy interval is 1000. As long as the timer is less than the interval, we keep increasing timer by delta time. Else, meaning that the timer has accumulated 1000 or more milliseconds, we set it back to 0 so that it can count again, and we call getEnemy to activate one object pool member. I set it to a variable and I call start method on that inactive enemy object to activate it. It will reset the object properties to default and it will mark it as active. There is a chance we don't have any inactive enemies in the pool when this code runs, which would break our code, so I only want to trigger start method if getEnemy method was actually able to find an available inactive enemy object. I delete this console log and I will call handleEnemies from inside render method, which means it will be called over and over for every animation frame. I will console log enemy here, and I see that it is correctly activating one enemy every 1 second. I delete the console log. Each enemy object has update and draw methods, and these methods only run when that object is active, when its free property is set to false. I can now run for each method on the enemy pool, and for each enemy object, both active and inactive ones, we call their update and draw methods. I put width and height up here, and I want the initial vertical position to be minus height, like this. This is how you implement a simple object pool design pattern with JavaScript. We are activating new enemy object every 1000 milliseconds, and we are returning them back to the object pool when they move off screen. Reusing our objects like this, rather than constantly creating new ones and deleting old ones, will improve performance of our codebase, especially in projects where we have large quantities of objects. I can make them float into view very fast and then start moving at their regular speed, like this. As soon as the entire object is fully visible, it will slow down. This small detail will look even better when we add graphics and animated sprite sheets. We want this project to be fully responsive. When users play on mobile devices, they will not be able to change the screen size, but we could have some situation on computer screens or devices where we are swapping between landscape and portrait mode, or when we are switching to full screen mid-game, where the game area changes in size. To account for these unlikely but possible scenarios, I will make sure that all the active enemies are always inside the visible game area. If the right edge of the enemy rectangle is past the right edge of game area, move it. Now, if the game area changes size mid-game, it will just push the enemies into the visible game area, making sure we don't have any active enemies floating off screen where we can't hit them. We will hit enemies by mouse and by touch events. We will create a custom mouse object and we will give it X, Y, and pressed properties. This will help us to make the mouse position available all over the codebase, not just inside the event listeners. Same as we did with resize, I will automatically apply mouse down event listener here inside the game class constructor. I need to use ES6arrow function here to make sure this keyword points to the game object from inside its callback. Inside, I could call prevent default in case the event is doing something we don't like. It might be more relevant later with touch events. We will test it and see. For now, I don't think I need it here. From here, I set X and Y position of the mouse down event to X and Y properties of our custom mouse object, making them available in an easier way all over the codebase. I will console log the auto-generated event object, and we are accessing these X and Y properties here. If your canvas is not covering the full browser window, we would have to use offset X and offset Y from here instead. I will console log these values just to check if everything is working. I click around and I'm getting X and Y of the click. Nice! I will create a reusable check collision method. We will use it to check collisions between enemy and mouse, but it can be used for other features later as well. Custom check collision method will take rectangle 1 and rectangle 2 as arguments, and it will use the usual 4 lines of code to check if two rectangular objects collide. Both objects passed to this method, both rectangles, need to have X and Y position and width and height properties for this to work. I will directly evaluate the expression and I will just simply return true or false whenever this method is called. The usual common formula for collision detection between two axes aligned, meaning non-rotated rectangles, check if the left side of rectangle 1 is to the left of the right side of rectangle 2. At the same time, we check if the right side of rectangle 1 is to the right of the left side of rectangle 2. If both of these checks are true, we already know that the rectangles collide horizontally, but they can still be far apart vertically, so we need 2 more checks. At the same time, we need to check if the top edge of rectangle 1 is above the bottom edge of rectangle 2. And at the same time, we also need to check if the bottom edge of rectangle 1 is below the top edge of rectangle 2. Only if all 4 of these checks are true, we have a collision. Even if one of these 4 checks is false, we know the rectangles are far apart and they cannot collide. This entire expression will return false. Now we need to make sure that whatever object we pass to check collision as rectangle 1 or rectangle 2 needs to have x, y, width and height properties. Otherwise the collision check wouldn't work. We will check for collisions here. We are inside update method on enemy class. If check collision method we just defined between this enemy object and mouse object returns true, we call reset on the enemy, returning it back to the object pool. I get an error. I need to make sure mouse object has width and height properties. It will be just a very small rectangle, 1 times 1 pixel. The problem is that when I click somewhere and move the mouse away, that mouse down event placed my custom mouse object there and it is still colliding with enemies. When mouse down event fires, we set mouse pressed to true. I create another event listener for mouse up event. In there, I will also update x and y coordinates to that last known location and I will set mouse pressed to false. Now I can add one more condition. If this enemy and mouse objects collide, and only if mouse is pressed at the same time, only then reset the enemy. Now I can click the enemies and they will correctly reset and return to the object pool. I could do other things here. For example, when I click them, they slip down like this. We will use that for something later with our phase-in dimension shifting alien. I go back to reset here. I can clean this code up. Since we are defining values of x and y inside the start method, we can just declare the properties here without any values, because we know that the start method needs to run anyway before the object is drawn in the game. It's cleaner because now, if I want to make any changes to these values, I just do it inside the start method. I don't have to check these values in 2 separate places. Enemies can also have multiple lives. I can just define it here, but I will only assign it value inside start method. That way, when we reused an old enemy object, its lives will be reset back to the original value. Each enemy will have 2 lives. We need to hit it 2 times. I will draw the lives here using the built-in fill text method. We pass it 3 arguments, the text we want to draw and x and y coordinates of the anchor point in relation to which we want to draw that text. I will put that anchor point exactly in the middle of the red enemy rectangle. We need to set fill style of the text to a different color, for example blue. In main.js, inside the resize method, which also runs on the first page load, we will set canvas font property to 50 pixels bangers. We put the text anchor point exactly in the middle of enemies. There are 2 canvas properties that handle the relationship between the text and its anchor point. We can set text align to center to align it horizontally. And we can set text baseline to middle to align the text vertically, exactly over the anchor point coordinates as we defined them on line 49 in enemy.js file. Now, instead of immediately resetting the enemy when we click it, we will reduce its lives by 1. The collision registers once per animation frame, so the lives decrease very fast. Before we fix that, we also say if the lives of the enemy are less than 1, we reset that enemy, returning it to the object pool. We will need this check later in multiple places. To make the code easier to read, I will put it inside a separate helper method. IsAlive method will directly evaluate this expression, and it will return true if the enemy is alive and false if its lives are less than 1. If enemy is not alive, reset the enemy. Now we need a flag that will indicate if the mouse click was already used to fire our weapon, because we only want to fire once per click. I give mouse a new property called fired. Initially it will be false. The shot hasn't been fired yet. We only decrease enemy lives by 1 if fired is false, and then we immediately set fired to true to make sure this code block runs only once. Then we need to kinda reload our weapon and set fired back to false so that we can shoot again. I think we can set fired back to false on either mouse down or mouse up. Let's try. Yes, this works. Now we remove only 1 life per click. We need to click each enemy twice to deplete both its lives and reset it. I remove the fill style here. Instead, I set it to white here. I will also set stroke style to white as well. It's better for performance to put these declarations here inside the resize method that runs only once on the first load, or when we resize the screen. Draw method runs 60 times per second. Declaring fill style here is less efficient when it comes to performance. I delete this fill style. Smaller font. We have a responsive world that resizes to accommodate for any screen size, vertical or horizontal. It will work on a massive super wide computer screen, it will work on tablets, and it will work on mobile, in landscape as well as in portrait mode. Let's make it even more mobile device friendly by including touch events. I could create a separate custom touch object, but I will actually use this.mouse object, which will work perfectly here. It will automatically work for both mouse clicks and touch events. Touch start will basically do the same thing as mouse down. Touch end event will do the same thing as mouse up event. This will not work yet because for touch events, this auto-generated event object structures the information about the event in a different way. I console log it. Here in Google Chrome browser, I click Device Toolbar to trigger responsive screen view, which will allow us to emulate touch events. In the responsive view, I click on Screen, and I know it worked because we are console logging touch event object. I'm looking for X and Y coordinates of the touch start event, and I can see that the browser organizes the contact points with a touch surface inside this touch list property. I think we can treat it as an array. We will test that later. I can see that to access X and Y coordinates of the touch event, I need to access these. So event.changedTouches, element with an index of 0, dot page X and page Y. I also do the same for the touch end event. Now we have a responsive game world, and we can use touch events to shoot enemies. I will disable device toolbar in Google Chrome, so now we are viewing our game in a regular computer browser view. I can put the code to display score and other game text directly inside render, but I want to keep this clean, so again I will put it into a separate method. It will make our codebase easier to navigate in. Inside the drawStatusText method, I will call built-in fill text method, and I pass it the text I want to draw and X and Y coordinates of the anchor point in relation to which I want to draw that text. I call it from inside render. I can see that the score is not fully visible. I want the text that displays enemy lives to stay centered, but I want the score text to be left aligned, so I wrap it between built-in save and restore methods that will restrict any changes I make to canvas state to this area, and all the drawing code outside this block will remain unaffected. That way I can have text align left for score and text align set to center for enemy lives. Score text will now flow to the right from this X and Y anchor. Let's actually count the score. I define it here. Start method. Inside we set score to 0, because this will also be used as a restart method. Now I add this variable here. Smaller font. When we deplete enemy lives by shooting it, we reset the enemy, returning it back to the object pool, and we increase game score by 1. I need to spell score correctly. If we have multiple enemy types, we could also here add score that is relative to enemy lives, for example, or each enemy type can have its own score property that will define how much score it awards. Now, when we click enemies, we get score points. I also want to give the game lives. These are the player lives. If we lose them, we get a game over. Don't confuse it with lives on each enemy. These indicate how many times we have to hit each enemy. These are player lives. When we start or restart the game, we set player lives to, for example, 10. Inside the draw status text, I will create a for loop that will run once per each life. I will draw a simple rectangle representing each life at first. It needs X, Y, width and height. Now I'm drawing all of them on top of each other. Okay, so this is X, Y, width and height. This value will be the margin from the left. I multiply horizontal X position by the index from the for loop, which will align them in a row next to each other. If the width of each life rectangle is more or equal than the spacing value, it will look like a continuous health bar, which might be something you want. If the spacing is more than the width, we get to see individual lives. I will go for this view because later I want to change each life into a different humanoid alien species. It will add more stakes to our space horror game because we don't want the enemies to eat our unique crew members. If this is not clear, just play with the values, watch what happens. It's pretty straightforward. If enemy manages to travel all the way across the screen, all the way down, and we don't interrupt it, we don't shoot it, it managed to catch up with our escaping fleet and it will eat one of our crew members. We reset the enemy and we reduce game lives by 1. If we change the number of lives, the rectangles representing each life will appear. This works well. Let's close the game loop. Winning score will be 3. We will display 3 messages on screen when the game is over. We will have 3 sets of these messages. One message will get displayed only on the first load before we press the button to start a game. I remove this value from game over. When we start the game, we set game over to false. I will create a separate trigger game over method to make sure this code block runs only once. At this point, I could put this logic inside render, but if I put it into a separate method, it will make it easier to play a special horror sound later when we win and when we lose the game. It will run only once when called, and we make sure of that by only running its code when game over is false. And inside, we immediately set game over to true. We triggered game over, which could mean we lost the game. Player lives are less than 1, or we won the game when the score is more or equal to winning score. When we lose, we set some unique text to message 1 and message 2. And if we win, we give those same variables different text. Then we need to call that method. I can do it from render or from draw status text here. If this.lives is less than 1, or if this.score is more or equal to winning score, we call trigger game over, which will set game over to true and it will set the messages up. Then, if game over is true, we want to draw message 1, 2 and 3 in the middle of the screen. text align center, large font, maybe 80 pixels bangers. We call fill text, message 1, and X and Y coordinates will be the middle of the game area. Message 2 and message 3 we do the same. I adjust their vertical coordinates to try and align them. -25, message 1, +25 for message 2, and +50 for message 3. I play, I wait until we lose. Okay, that worked. I want messages 2 and 3 to be drawn in a smaller font. I try 20 pixels. That's the losing message. I refresh the page, I play again, and I win. Winning message. We have one more message. We will make a display in a minute. I set game over to true. I created this reset button here. I wanted to trigger start method when clicked. First, I create a property on the main game object, and I point it towards that button element using its ID. Then I add event listener on that button. We listen for a click event. Again, I have to use an arrow function here to make sure we have access to this dot from inside the event listener, to make sure that this keyword points towards the game object. From there, I call this dot start. Now I can see the start messages, but they are not formatted well. I fixed that by calling this dot resize automatically from inside the game class constructor. Doing this fixes fill style and text baseline settings, but now score is undefined, so I will initially set it to 0 here. Inside handle enemies method, we periodically activate new enemy object and add them to the game. I only want new enemies to keep coming if game over is false. Now, when I refresh the page, we just see the starting set of messages and nothing is happening until we click on button R here to start the game. Having a button that starts the game by user interaction will also solve issues with game sounds. We will talk about that later, but basically in modern browsers, sounds will play only after the user interacted with the document, and user clicking this button will count as an interaction, which will allow the sounds in our game to be played. I create another event listener, this time for a key up event. I console log the event object. We are looking for this key property. I say if e.key, the key that was pressed on the keyboard, is enter, or if the key is R, I use two lowercase method here to account for both lower and uppercase being pressed. We run a start method to start the game. R needs to be in quotes here. Right now, start method will basically just reset the score back to 0 and it will replenish our lives. I also want to reset all active enemies. I run over all objects inside enemy pool array and I call reset on them. Maybe I want to activate 2 enemies quickly immediately as the game starts. I could do a for loop like this. I try to get enemy. If there was an available free enemy object we found, we activate it by calling enemy start method. Don't get confused here. Start method that sits on the game object starts and restarts the game. Start method we defined inside enemy.js on the enemy object activates enemy object pool member. 2 different methods. Now we can start or restart the game at any time by clicking or tapping on this R button, or by pressing Enter or letter R on the keyboard. This is just to show you how you can give your players different options. We can also create a faster initial wave by immediately activating a few enemies in the beginning here. Then the rest will be coming in 1 second intervals. Modern web development has a lot of cool features. Have you tried to use built-in full screen functionality before? Basically, it just removes the browser buttons and navigation bar, and it will expand your application to take up the full screen. This will work on computer monitors, on tablets, as well as on mobile screens. We will use it to make a proper full screen game now. It's very simple to implement it. Let me show you. Are you interested in full screen games? Let me know by leaving a comment, and if people like it, I can use this feature more often for other projects. You can go to this web address to read the documentation if you want more details. All we need to make this work is this simple if-else statement that basically says if full screen is currently not active, activate it. If it is currently active, deactivate it. All these properties are built into every modern browser, so you can simply just copy this small code block, and I paste it here on the main game class as toggle full screen method. Whenever this method is called from anywhere in our codebase, it will check is full screen active. If not, activate it. If it is active, deactivate it. We test if it works here, else if the key that was pressed is spacebar, or if the key that was pressed is letter F. Feel free to use different control keys here if you want, if you know what you're doing. Now I press letter F or spacebar, and my game toggles between full screen and regular browser view. I'm not really showing it off well here because I'm not recording the edges of my screen, but if you are coding along, you can do it yourself with your codebase and see that this is a very nice proper full screen functionality. We also want to be able to toggle full screen on mobile devices where there is no keyboard. For that, we have this full screen button I created earlier. You can also enable and disable full screen by gestures, for example by swiping up and down. If the swipe is longer than a set number of pixels, and when it is in a specific direction, we can trigger our custom code, which could be, for example, enabling and disabling full screen. I did that in a different tutorial for this simple mobile-friendly endless runner and jumper game. It was some time ago on my YouTube. Same as we did with the reset button, I reference full screen button in my code. I attach event listeners to it, and in the callback I call toggle full screen method. The game is fully playable in the full screen mode. What you see now is not completely right because I'm not recording my entire screen. So the planet and the text is a bit off center and the buttons are not here. But if you are coding along, you can see in your project that everything is working well. We have a blank slate of a game with a full set of features: complete game loop, win and lose state, mouse, keyboard and touch controls, reset and full screen functionality. This game will work on large horizontal computer monitors as well as on small vertical mobile screens. You can adjust winning score on line 16 or lives on line 77 to tweak the win and lose conditions. In the video description, I'm giving you a full source code from the project at this stage. You can compare it with your own code if you encounter some problems. You can take this code and use it to create many different games. Get creative with the themes and graphics and make it your own. In the next part, I will turn this into cartoon space horror game with sounds and randomized crew that we have to protect from phasing flesh-eating aliens. This concludes the beginner-friendly part of the course. In the next part, I will show you an improved implementation of state design pattern, and I will go a bit faster. Well done if you got this far. Let me know by leaving a comment saying I finished the beginner project. You can also click the like if you found some value and you want more tutorials like this one. We have a game that works on small and large screens, portrait and landscape, vertical and horizontal. Now it's time for fun. We add some graphics and animations. I set lives to 15. I create a div with an ID of assets. Inside, I will put our project images and sounds. You can download everything I'm using here in the resources section below. Crew PNG image, and the ID will be crew. I give assets display none. We want to hide everything in there. We just want to load those images in memory so that we can draw them with JavaScript on Canvas. I want to draw lives as little crew members. Let's start simple. I bring crew image into my project using getElementById here. Inside the drawStatusText method, we draw rectangles to represent player lives. Instead, I will use built-in drawImage method. We pass it the image we want to draw and X and Y coordinates where to draw it. I adjust width and height here to match the image we are using. This is the left margin. This is the spacing between the little crew members. I can make them have space around, or I make them stack up closer on top of each other. When we lose all crew members when they were eaten by the aliens, we lost the game. I want to create different enemy types. This is the main enemy class. It contains all methods and properties that will be shared between all enemy types. I will first do a simple enemy with the most basic implementation, but my ultimate goal is to show you how to use a complex enemy with multiple states and how to structure your code where each state is in its own dedicated code block using so-called state design pattern. Basic simple enemy with one life, no special features, no special abilities and interaction. I call it Beetlemorph, and I will go back to my Space Invaders game from a different tutorial and I will get the sprite sheet we used there. In this project, the enemies are a bit bigger. If you are watching the extended version, I'm giving you all larger exports of all enemy types we used in this entire space game series. If you want, you can play with this later and implement whichever one you want. For now, I will just grab the Beetlemorph sprite sheet in the resources section and I will put it into my project folder. Beetlemorph subclass extends the enemy superclass. Constructor will expect game as an argument, and I will pass it along to superclass constructor when we call it. So here I'm calling class constructor on the parent enemy class we are extending. That class is defined here. That will make all this code here run first. These are all the shared properties, the properties that are the same for all enemy types. On the Beetlemorph subclass, I will only define properties specific to this particular enemy type. It will have a unique image. I import it here. Download link in the resources section below. I point JavaScript towards the image using getElementById. It will also need its own start method. First, we will call the start method on the parent enemy class, on the superclass, like this. When we call start method on Beetlemorph enemy, it will first run all the code inside this parent start method here from line 13. I copy speedx and speedy, and when we call start on Beetlemorph, I will give them values. I want this enemy type to move directly down, so speedx 0, and some positive speedy. I remove these values on lines 8 and 9. They will be set to something different for each enemy type inside their associated start methods. I also remove lives from the shared start method, because each enemy type will have a different number of lives. In the extended version, I'm also going back to Space Invaders and Planet Defense projects, which are all part of the same big course, including this game and others, and I'm adding bonus lessons implementing the new phase-in enemy type that can only be hit when it is in the same dimension as the player. So, we are extending a class. Shared properties sit on the enemy superclass. Properties unique to each enemy type will sit on the subclass. First, we trigger constructor and start method on the superclass, on the parent class, and then we add some properties and values specific to this particular enemy type. Inside update method here, we check for collision between enemy and mouse. I will cut this and I will put it into a separate method. It's mainly because we will have a phase-in enemy type that cannot always be hit, so I need to be able to better control when we check for collision. Now it's in a separate hit method. So all this code inside update will be shared and executed for all different enemy types in our game. Beetlemorph will have its own update method that will override it. If this enemy object is currently active, we call all the code inside the update method from line 31, and then, if this enemy is alive, we call hit method, checking collision between this enemy and mouse. Now I need to call that subclass here. We push new Beetlemorph into the enemy pool. Right, I forgot here I have to call update method on the parent enemy class. That works. Now we want to draw the sprite sheet. I can put this code inside the draw method on the shared parent enemy class, because all the enemy types will have a sprite sheet. I call built-in draw image method and I pass it the image I want to draw and X and Y coordinates where to draw it. This will just draw the entire sprite sheet with all its frames at its original size. We can give it optional width and height here, which will squeeze or stretch the sprite sheet into the area we defined. We need the longest version of draw image method with 9 arguments. It will give us complete control over the sprite sheet. We pass it the image we want to draw, source X, source Y, source width, and source height of the area we want to crop out from the source image, and destination X, destination Y, destination width, and destination height to define where on destination canvas we want to place that cropped out piece of image onto. The sprite sheets we are using have individual frames size 100 x 100 pixels, so I define those properties here. And I set width and height relative to that. These two values are for cropping. These two values determine the size at which we will draw the image on destination canvas. These two sets of values don't need to be the same. We can scale this and we will do it later. So what if I want to crop out the top left frame from 0, 0 to sprite width, sprite height? Nice, we are using draw image method to crop out this frame from the sprite sheet. Frame Y property will help us to travel around the sprite sheet vertically. The way I organized this sprite sheet, you can see it will give us different variations of the same enemy type. All enemies will have 4 sprite rows, 4 variations, so I can randomize frame Y here inside the shared start method. If each enemy had a different sprite sheet, we would have to put this on each separate enemy subclass. Math.random times 4 wrapped in math.floor means that every time start method runs and we pull an enemy from the pool, it will randomly be assigned frame Y 0 or 1 or 2 or 3. Source Y argument passed to draw image method will determine the vertical cropping coordinate, so we pass it frame Y times sprite height. Frame Y can be 0, 1, 2, 3. 0 times sprite height is this, 1 times sprite height is this, 2 times sprite height, 3 times sprite height. This is one simple way how to randomize your sprite sheets a little bit and give us some variations of the same enemy type. They all have the same features and color palette, but they have different details. Makes it more interesting, I think. We will also need frame X to navigate around the sprite sheet horizontally. I will also have last frame property to define how many horizontal frames we have per row. When the start method on enemy runs to activate it, we set frame X to 0. Each enemy might have a different last frame. Beetlemorph has a very simple sprite sheet, only 3 frames per row. Inside the shared update method, we will handle horizontal sprite navigation. When the enemy loses all lives, when this.isAlive is false, we keep increasing frame X by 1. When frame X is more than last frame, we know that all the explosion animation frames have been displayed and we know it's safe to reset the enemy and return it back to the object pool. If game over is false, we increase score by 1, and I can delete this. Finally, as the source X argument passed to draw image method, which determines the horizontal coordinate of the cropping area, we pass it frame X times sprite width. When frame X is 0, 0 times sprite width, we draw this frame. 1 times sprite width, 2 times sprite width. I hope it makes sense. I play, I click each enemy twice, deplete its lives, and the animation plays. That worked. It is playing very fast. I want to be able to control how fast we jump from frame to frame when animating our sprite sheets. We will do another periodic event, same as we did before when we activate new enemy every 1000 milliseconds. We will update all sprite sheets in our game every, let's say, 200 milliseconds. Sprite update will be false. Every time sprite timer counts to 200, it will set sprite update to true. I can put that logic directly into my render method, but to keep our code cleaner, I will separate it out to its own code block. I will call it, for example, handle sprite timer. it will expect delta time as an argument. If sprite timer is less than sprite interval, we keep accumulating delta time. Else, once we accumulated enough, we reset timer back to 0 so that it can count again, and we will set sprite update to true, allowing our sprite sheets to jump from frame to frame. It will be true only for that single animation frame. All other times it will be set back to false. Now we call handle sprite timer here. This delta time value will get passed along, so that should be all good here. Inside the update method on enemy class, only if the enemy is not alive and if sprite update is true, only then jump from frame to frame in the sprite sheet. I will adjust this code block. We have to be very careful about the brackets here. It's easy to break our code with a single missing bracket. It doesn't work because I have to use sprite update here actually. And one more mistake I made somewhere. I see, I misspelled sprite interval here on line 24. I can slow it down or I can speed it up by giving different values to sprite interval here. 1000 milliseconds will make them animate very slow. $50 milliseconds is very fast. 150 milliseconds seems like a good value here for now. Now it all works well. We get one behavior I don't like here. If two enemies overlap and we click them, it destroys the enemy in the back. Why is this and how do we make it destroy the enemy at the front? We are cycling over the enemy pool and calling update and draw. We are drawing all enemies on the same canvas element, so in a single animation frame, as we run this for each method, we draw enemies one by one. The enemy we draw first will appear behind the enemy that was drawn after. At the same time, the collision checks inside update method will run first for the enemy that was drawn first, and that enemy gets destroyed. One way to fix this would be to run over enemy pool from one direction to call update, and then from the opposite direction to call draw. That way, the enemies that are drawn last, meaning on top, will get checked for collision first. With this code structure, when two enemies overlap and I click them, the one on top in the front gets destroyed. That's better. Since we separated the cropping size and the drawing size, we can actually do some scaling here. I can multiply width and height by the same size modifier value. I can make the sprites larger or smaller. How about a random size modifier between 0.4 and 1.2? Makes the game a little bit more interesting maybe. How about a random value between 0.6 and 1.3? I want to be able to show and hide some helper elements in the game, such as these white collision boxes and numbers displaying enemy lives. Let's create a debug mode. On the main game class, I create this.debug property, and initially I set it to true. Inside key up, if the key that was pressed to lowercase is letter D, we will set debug to its opposite value. If it's true, we set it to false. If it's false, we set it to true. Inside the draw method on enemy class, we only draw the white rectangle around enemies and enemy lives if the debug is true. I make sure I save changes to all my files, and now I can press D on my keyboard to toggle debug mode on and off. I give Beetlemorph only one life, because when we don't display enemy lives, that first click doesn't have any visual feedback and we don't know if we hit the enemy. I adjust size modifier range here on line 6. I set winning score to 20. Initially, debug will be set to false. If you are happy with having just simple enemies like this, you can implement them the way we just did. I created a series of games and projects with this art style, and all the art assets are compatible and can be used between the projects if you want. I will now grab one of the more complex enemies we implemented before, and I will try to implement it in the same way we just did. And then we will add a third enemy type using state design pattern, which has a little bit more complexity but gives us much more freedom while keeping our code clean, modular and organized. In the other projects we have, for example, an armored enemy, inflatable enemy, vengeful enemy that shoots back at us. We have an oversized boss enemy type with a massive health pool. We have a charging enemy that will speed up and hit us. I will grab, for example, this one, an enemy that splits into clones when we hit it, because I have an interesting idea on how to use it in this particular project with this type of gameplay. In this class we are using slightly larger sprite sheets with frames 100 x 100 pixels. You can use the sprites you already have if you followed the other classes. They have frames 80 x 80 pixels. In the extended version of this project, I will also include exports of all enemy types in 100 x 100 frame size to better match this project. So if you want to play with this codebase later and include the other enemy types as well, you can use those bigger sprite sheets. So I included my image in index.html and I referenced it here. Last frame will be 14. Again, start method will first trigger start on the parent enemy class. Horizontal speed x 0, speed y will be a random value between 0.2 and 0.7. This enemy will have 3 lives, so I need to make sure it's a bit slower to give the player enough time to deal with it. My plan is this: enemy has 3 lives. We hit it once, the frames will play until here. We hit it again, the frames will play until this point. We hit it the 3rd time and the rest of the sprite sheet will play. This would be best implemented using state design pattern when each of these states has its own code block, but I will try to implement it somehow in a simple way like we did with the beetle morph. Then we can compare it with the last enemy where I actually show you how to use state design pattern. You can compare the relative complexity between these two approaches and you will see the advantages of the final approach. Update method will first run all the code inside the update method on the parent superclass. Then, if this enemy object is currently active, if the enemy is alive, we will make it react to being hit by the mouse. We will have a horizontal frame range defined by minFrame and maxFrame helper variables. If frame x is less than maxFrame, and if sprite update is true, we increase frame x by 1. Okay, so what I'm doing here, frame y handles vertical sprite navigation. Frame X handles the horizontal sprite navigation. Last frame is the last horizontal frame. Once it was displayed, we know the enemy can be deactivated. MinFrame and MaxFrame will define some animation range we are currently working with, depending on which state the enemy is currently in. There are many ways I can implement this. I want to do it in the simplest way possible, so we are going to do if-else. If enemy lives are more or equal to 3, MaxFrame is 0. If enemy lives are 2, max frame is 3. So when we hit the enemy once, because of this line of code, it will animate from here and it will stop here. Else, if enemy lives are 1, we will let animation go all the way to max frame 7. I think that might be enough because we have some other animation code inside the shared update method that when enemy is not alive and has less than 1 lives, it will animate the rest of the sprite sheet, the explosion frames automatically. Let's see. Here, where I create the enemy pool, I want to randomly create beetle morph or lobster morph enemy types. I can, for example, roll a random number between 0 and 1. If the random number is less than 0.8, so in roughly 80% of the cases, we create a lobster morph. In the other 20% of cases, we create a beetle morph. Okay, both enemy types are coming. I click the enemy once, twice, 3 times. That all worked perfect. I adjust sprite interval to make the animation a little bit faster. This code block is working well, but when you write your code, always think about which code is running once and which code runs over and over. This code is running all the time and I'm setting max frame to the same value 60 times per second over and over. Also, what if I want to play a particular sound when the enemy morphs into the next stage? I don't really have a good place to put that code here since this code block is running over and over, so that sound would be played over and over if I call it here. Ideally, I need some code block that runs only once to play that sound for me. We will solve all these issues in a minute. First, let's use sprite sheets for crew members. Right now, all our crew members look the same. Let's give them a little bit more personality. An intergalactic crew of different kinds of humanoid and robotic crew members. All the art assets are available to download in the resources section down below. I bring crew sprite into the project, give it some ID, and I point crew image to this new sprite sheet. How do we do this? I will actually have to hold the randomized coordinates to crop these frames out somewhere, maybe here inside crew members property. I set it equal to an empty array. I create a helper method I call generateCrew. Inside, I set crew members to an empty array, deleting everything in there, in case it's not empty when we call this method. Then I run for loop. Each player live will have a random crew member image assigned. Each crew member will be a simple object with frame X and frame Y property. Frame X will be a random number between 0 and 5, and we use math.floor to round it down to the nearest lower integer, and it will be 0 or 1 or 2 or 3 or 4. Same for frame Y. Each time we push new crew member, it will get some random coordinates somewhere on this sprite sheet. We will call this method every time we start or restart the game, after we set value of this.lives. That's important. Here in drawStatus text, I define width and height of a single frame in crew members sprite sheet. I need to add 4 more arguments to define the cropping area. For example, I can crop out the top left frame from the coordinates 0, 0 to width and height. I will also use width and height here in destination width and destination height arguments to define the size at which they will be drawn on canvas. We always have to start our game to see the lives by pressing Enter, letter R on the keyboard, or by clicking or tapping on this R button. Nice. So now let's use frame X coordinate from crew members array. We created that property here on line 100. So as we cycle in this for loop 15 times, because we have a total of 15 lives, we use the index from that for loop to access the corresponding element inside crew members array, and we access those frame X and frame Y coordinates, and we multiply them by width and by the height of a single frame to correctly travel around the sprite sheet. Now, every time I start or restart a game, we generate a set of humanoid and robotic alien species. I hope it puts a little bit more pressure on the player to try and make sure none of our unique crew members get eaten by the aliens. This value here defines the left margin. This value here is the spacing between the images. We have a simple enemy type and more complex enemy type implemented in the simplest way I could think of. We have a randomized set of crew members, and we need to protect them from hungry flesh-eating aliens. If you are watching the extended version, there is a source code available to download from this stage of the project. If you struggle with something, feel free to use it and compare your code with mine. If the spacing here is a little bit less than the width of a single frame, we will get them stuck up behind each other. You can play with these values and use whatever looks good for you. Now it's time to learn how to use state design pattern to implement a phasing enemy type that can only be hit when it's in the same dimension as the player, when it's in a solid state. If you hit the enemy when it's phasing, when it's in the invisible state, it will boost it and speed it up, making it even more dangerous. We will also attach sounds to different phases and actions because it's important that our games give player feedback when you click or interact with something. So we will give visual feedback by animating the enemies, and we will also get audio feedback by playing a specific sound. Small bug to fix: I only want to reduce player lives when game over is false, like this. I bring a phantom morph sprite sheet into the project and I give it an ID. Here we have the shared enemy class with all shared methods and properties. We are extending it into a simple beetle morph enemy and a more complex lobster morph enemy type, and now we will extend it into the most complex phantom morph enemy type. I was having a lot of fun with this, and if you are watching the extended class, I went back to Space Invaders and Planet Defense projects, and I added a bonus lesson to each one, as well as the full source code where I implement this phantom morph, a phasing enemy type, into both of these projects. You can also just take the sprite sheet I'm giving you here and try to implement it yourself if you followed those classes, but if you need my help, those lessons are there for you. Phantom morph will have last frame 14. Some speed X and speed Y. We will change these in a minute, and it will only have one life, but it will not be that easy because you can only hit it when it's not phasing, when it's solid. If you hit it at the wrong time, you can accidentally give it a boost and cause one of our crew members to be eaten. And it's probably not going to be pretty because if you listen to the sounds that will play when that happens. I go to the main.js file, here inside create enemy pool, and I will only create phantom morphs. I have to be careful about the brackets. I save changes to all my files, and here we go. I will copy update method from beetle morph code block, and I use it here. Now, when I hit it once, it will just play the rest of the sprite sheet as expected. Vertical speed will be a random value between 0.2 and 0.7. I also want to make them move left and right. Horizontal speed will be a random value between -1 and +1. We want to make sure they can't move off screen, so I will make them bounce left and right. If the horizontal x coordinate of the enemy is less or equal to 0, or if the right edge of the enemy rectangle is touching the right edge of the visible game area, in both of these cases, just flip horizontal speed to its opposite value, making the enemy bounce and move in the opposite direction. Perfect, that worked. The other enemy types were static, always showing a single animation frame unless they were animating into another state. This enemy type will be different. I want it to always animate in a certain frame range. Initially, min frame, minimum frame will be 0, and maximum frame will be 2. I give this enemy type its own special method that will handle animation frames for me. If sprite update is true, we move horizontal frame. If frame x is less than max frame, we keep increasing frame x. When we reach max frame, we set it back to min frame so the cycle can continue. I will call handle frames from inside update here. Nice. So this will be the frame range for the basic flying state, and I try 3 to 5 probably. That will be the phasing state animation range. Okay, if you are a beginner, now comes the complicated part. We are going to implement state design pattern that will allow us to define properties and behaviors of this enemy for each state separately in its own code block. I create a completely separate class called enemy_state. Constructor will expect game and enemy as arguments. We will need these to be able to point towards and access our main game object and also the particular enemy object that will be in these different states. Then we will define each state in its own subclass. All of these 3 subclasses will extend the main enemy state class. Here we will store the shared properties, and inside each of these code blocks we will define properties, values and behaviors we want the enemy to have only while it is in these particular states. It gives us a lot of freedom and flexibility, and it makes our code easier to debug, because if we get an error and we know which state the object was in, we know where in the code to look to fix it. The only challenge for beginners will be to keep track of how all these objects connect and communicate with each other. If you are a beginner, the next part will be challenging, so don't worry about it too much. This is one of those techniques you have to use a few times to create kind of a mental map. It helps if you use this for a few different projects. It becomes easier to navigate eventually as you get used to it. All you need to understand now is that we have a separate enemy state class. We are extending it into 3 state subclasses: flying, phasing, and imploding. Each of these classes will have its own start method, where we define, for example, frame range for the animation. While the enemy is in that state, we can also play a specific sound from here when the enemy enters that state. Each state will also have its own update method that will first call the shared update method on the main enemy class, and then it will add a little bit of unique logic that will only apply when enemy is in that particular state. For example, maybe we only want to check collision detection when enemy is flying. When the enemy is phasing, it cannot be hit, so we will not run check collision method from there. Things like that. Each enemy object will have an array of all possible states it can be in. Inside, we instantiate all 3 state subclasses like this. Here on line 174, I can see enemy state constructor expects game and enemy as arguments, so I pass it this game reference along. Through this reference, we will be able to see player lives, score, or game over state, all the things we might need that sit on the main game object. Then I will pass it this keyword representing this particular enemy object. This keyword used here in this code block means the enemy. Through this second reference, we will be able to access all the methods and properties that sit on the enemy object, on the enemy class. This is probably where it's getting a bit more complicated for the beginners. Just keep going, I will try to guide you now. Phantom Morph will have a current state property that will be pointing towards different states we have here inside this .states array, and through this connection we will be able to set enemy to a different state. Custom set state method will expect state as an argument. This state will be a number, representing index in this .states array from line 139. 0 will be flying state, because this is an array, and arrays start from the index of 0. 1 will be the phasing state, and 2 will be imploding state. When we call set state, we take this .current state property from line 140, and we point it towards one of the objects inside this .states array, 0 or 1 or 2. At that point, this .current state holds an entire instance of, let's say, flying class, and we gave that class its own start method. So I set current state to flying class, and I call its associated start. We define that method here on line 186, and the job of this method is to set properties on the Phantom Morph enemy to whatever values they need to be when Phantom Morph enemy type enters this state. We need to make sure each state subclass has its own start method. We have multiple layers here now. When we call start on the Phantom Morph enemy type to activate it from the object pool, we first run the code that is shared for all enemy types. Then we run the code that is specific only for Phantom Morph enemy type. Then we call set state method. We set the current state to an instance of flying state subclass, and from there we call start method on the flying state, which will set properties to that particular Phantom Morph state. It will be the same inside the update method. When we call update on Phantom Morph enemy class, first we call all the code inside the update method on the shared parent enemy class. Then we add some code specific only to Phantom Morph enemy type, and on top of that we trigger that last bit of code specific only to the current state Phantom Morph enemy is currently in. Depending on which code block current state is pointing towards at the moment, it could be this code block from line 191, or this code block from line 200, or this one from line 209. So now we have all the layers and you can place your logic wherever you need it. Do you have an idea for a behavior that is specific only to one of these states? We created a space for you to put that code in. I will show you some examples of how this is done. This is the entire state design logic loop. I'm not sure if I explained it well enough. If you still don't fully understand it, let me just expand each code block and see what happens. Hopefully, while we work with this, it will become more clear. With this code structure, we have a complete and detailed control over our objects. We can do so many different things, and basically we can do anything we want with our space creatures now. We can access properties on the enemy through this.enemy reference. When we enter flying state, we set min frame to 0 and max frame to 2. This means I can remove those values from here because they will be triggered when this line runs anyway. When we enter phasing state, we will set min frame to 3 and max frame to 5. When we enter imploding state, min frame will be 6 and max frame will be equal to last frame plus 1 maybe. When we activate the enemy, it is set to state 0, flying state, and this start method sets the frame range, as we just defined. We can also make them start from the phasing state. I can see they start from frame x0. I actually want them to start from whatever the min frame is in that range, so I can say this.enemy.framex is equal to this.enemy.minFrame. And I do the same thing here and here. Now they are immediately invisible. They start from the correct frame range when they enter a particular state. I want them to be randomly starting from either flying or from phasing state. I want 0 or 1 here, so math.random times 2 wrapped in math.floor will do that for us. Now we get some enemies start invisible, some start invisible. I want the enemies to automatically switch between flying state and phasing state. We already used periodic events to activate enemy every 1 second and also to allow sprite sheets to update every 120 milliseconds. We can use the same technique for this. Each enemy will have its own switch timer and switch interval. I put them on each enemy object. Each enemy having their own timers will allow us to, for example, give each enemy different interval. If I wanted all enemies to switch states at the same time, for performance reasons it would make sense to put this logic on the main game class. For now, I want each enemy to switch state every 2 seconds, every 2000 milliseconds. We will randomize this value in a minute when we get this working. I can put that logic here. If the enemy is alive, we will make it periodically switch between flying and phasing state. If switch timer is less than switch interval, keep increasing switch timer by delta time. Else, meaning if switch timer accumulated enough milliseconds, set switch timer back to 0, so that it can count again towards the next periodic event, and call custom switch method, which we will define now. Switch method will simply check if this.current state from line 140 is equal to this.states index 0, which is the flying state as we defined it here on line 139. We call set state and we pass it index 1, phasing, which will reassign the current state to phasing. And it will call start to adjust the frame range and so on. Index 1 is here. I could have created an enum object translating 0, 1 and 2 indexes into something more readable, but I think since we only have 3 states, we can work with numbers. We just have to remember index 0 is flying, index 1 is phasing, index 2 is imploding. Else, meaning the current state is phasing, we set state to 2 to activate the imploding state, just to see what happens. We are using delta time here. We are calculating it on line 215 inside main.js. We are passing it to the render method. Then we are passing it along to update method on enemy objects. That goes here inside enemy.js. It is available to the main update method on the enemy class, but we don't really need it here. So we can just go directly to the phantom morph class and just access delta time here. And then it will be available to our state switching logic. We are switching state between flying and imploding, which results in this. We actually want to switch between flying and phasing. That's better. I can randomize this interval to make it more unpredictable. I want the enemy to be destroyed when we click it, only in a flying state. If we hit it when it's phasing, we will give it a speed boost. This will encourage the player to time the clicks properly. Here on the Phantom Morph subclass, if the enemy is alive, we call this.hit method that sits on the main enemy class. I will actually intercept this. I will give it its own hit method. That will first run all the code inside the hit method on the parent enemy class, here on line 34, to check collision between mouse and the enemy object. When we hit the enemy by clicking it with the mouse or tapping on it with our touch events, we will check if the enemy is not alive. We will switch it to the imploding state, set state 2. I will cut this code block. We want to call hit method only from while we are inside the phasing state or inside the flying state. I will remove hit method from phasing state. Maybe the enemy cannot be hit when it's phasing, when it's invisible. It can only be hit when it's flying. I can see that we are displaying explosion animation frames too fast. I will remove this handle frames method that cycles between min frame and max frame, and I will only call it while we are in flying state or in phasing state. When the enemy is imploding, we don't need to handle frames anymore, because this code block on the shared parent enemy class will take over, and when the enemy is not alive, lives are less than 0, we keep increasing frame X until we reach last frame, and then we reset the enemy. Okay, good, we cleaned that up. I could do all kinds of things here. Maybe when we click the enemy, I copy this code block, I put it here inside the phasing state. If we click the enemy while in phasing state, we give it a speed boost. We push it vertically by 25 pixels. Maybe I can remove this mouse fired check for this, and we are inside state subclass, so I have to say this.animate here. If we click an enemy while it's phasing, we make it jump forward instead of destroying it. If we click it when it's in a flying state, we switch it into imploding state, and when explosion animation frames finish playing, we get a score point. I could, for example, copy these two lines, and every time we enter flying state, I add enemy dot here and here. And every time we enter phasing state as well. We randomize speed X and speed Y again to make sure the enemy changes direction. And if we click the enemy while in phasing state, we make it move directly down, so speed X 0 and speed Y will be 2 pixels per animation frame. When we click the enemy when we are not supposed to, we are giving it a speed boost, making it more likely to eat one of our crew members. Okay, so we have a shared enemy class. We are extending it into a Phantom Morph subclass. This enemy type can be in flying, phasing, or imploding state. We are switching between these states by pointing current state property to different state subclasses using this set state method. And we are calling update on the current active state subclass from here. With this code structure, we have a separate code block for each state, and we can add any behaviors and properties to the enemy here. This allows us to control every detail and keeps our code clean and organized. We gave our enemy a flying state where we animate this frame range and enemy can be hit and destroyed. Phasing state where we animate this frame range and enemy will get a boost if we hit it in this state. And imploding state, which will just animate the destruction of the enemy. The way I structured my code, we need to keep this update method here, or our code would break. If you don't want it here, because we are not using it for anything right now, you can also put it on the parent enemy state class, and JavaScript inheritance will make sure the code will still work. Structuring our code in this way has so many advantages. I prepared a set of sound effects for this game. Let me show you how easy it is to implement it now. You can download my horror sound set in the resources section below. We will bring them into the project here inside the assets div. I create a HTML audio element and I point it towards my new game mp3 file and I give it an ID of new game. One more, let's take boom1 mp3, ID will be boom1. Up here in main.js I create a class called audio control. Constructor will just have a property for each sound pointing to the audio element using its ID. I create an instance of this class so the sounds will be available from this.sound property sitting on the main game class. When we start the game, I can simply just take this.sound.newGame and I call built-in play method. Most modern browsers will not play audio automatically when a web page loads. In our project, user has to press Enter, R, or click this R button to start the game. That is considered a user action and it will allow game audio to play. We have another sound called boom1 here. I go to enemy.js. Down here inside the imploding state, when the enemy enters this state and start method runs, we can play it. Now we will notice a problem. When I quickly destroy multiple enemies because we are accessing the same audio element, the sound will not start playing until the previous loop finished. I want the sound to play each time we destroy an enemy. We could create multiple instances of that sound, which would not be performance friendly, I think. I can use Web Audio API here, which gives us much better control over sound. Or the simplest solution here is to simply rewind the sound to the beginning every time it's supposed to play. It might sound strange, but it will actually create the effect we want. Let me show you. I create a custom play method here. This method will take audio as an argument, which will be one of these. It will rewind it to the beginning by setting its current time property to 0, and only after that it will automatically call the built-in play method. So I need to call the custom play method like this, and I need to pass it the audio I want to rewind and play like this. Now, even when I quickly destroy enemies, the audio reacts. We will improve this sound even more, but before we do that, I import slide.mp3 and I give it an ID of slide. I want to have visual and audio feedback to every important action the enemy takes. I bring it into the project here, and inside the phasing state, if we click the enemy while it's invisible, while it's phasing, we will play the slide sound. Now, if the players click the enemy when they shouldn't, while the enemy is phasing, it will give the enemy a speed boost, and we will also get an audio confirmation that it happened by hearing the slide sound. I bring more boom effects, boom 2, 3, 4, and I give it IDs of boom 2, 3, 4. I bring them into the project here, inside the audio control class. When we destroy an enemy, I want to play boom 2, a slightly different version of the sound. I save changes to all my files. I press Enter or R to start the game. Nice. Now boom 2 plays. Let's test boom 3. I added some squishy slime undertones when I mixed this one to make it extra juicy. Boom 4 has some cracking and flapping noises in there. When we destroy an enemy, I want one of these 4 sounds to be played randomly. I create an array called boom sounds and I put all 4 of them in there as elements. When we destroy an enemy, the sound I want to play is one of the indexes in boom sounds array. So instead of hardcoding index 1, I want a random number between 0 and 3. When I do this, it will give me an integer, either 0 or 1 or 2 or 3. I play. I destroy enemies and random sounds are playing. Perfect. We also have a victory sound when we win a game, scary horror sound when we lose, and we have a horror scream when one of our crew members gets eaten. To figure out where to place the code that plays these sounds, we need to understand which code blocks are running over and over for every animation frame and which code blocks run only once. I want the losing sound to be played only once when game over happens. I can do it here inside our custom trigger game over method. If the player lost all lives, if all the crew members were eaten, we play the lose sound. If the score is more than winning score, we play the win sound. I go to enemy.js here on line 57. Inside the update method on enemy class, if the enemy moved all the way across the screen from top to bottom and we didn't destroy it, player will lose 1 life. 1 crew member will be eaten and we will play the scream sound. Okay. I set winning score to 3, so we can test this easily. We have 15 lives here on line 108, 15 crew members. When the enemies get to the bottom, they will start getting eaten. It's a bit strange when multiple enemies reach the bottom. The scream sound gets reset from the beginning as we designed it, but I don't think it works well in this particular scenario. When we lose all lives, we get lost sound. That worked. I restart the game and I kill 3 enemies. I win the game and the winning sound plays. We have a nice set of sounds and they don't have only an aesthetic effect. They also have a gameplay effect, giving the player audio confirmation that the interaction was registered and actioned. I don't want to rewind the scream sound, I only want it to play again when the previous scream fully finished playing. I will play. Let's lose some crew members and see. Now, when multiple enemies get to the bottom, we don't get a scream sound for each lost crew member if they get lost too fast. But I think it's cleaner when we are not resetting this particular sound until it's finished. Now it might be a good idea to adjust your winning score and player lives to make the game as difficult or as easy as you want it to be. If you are testing it on a mobile device, you can leave a quick comment and let me know if it worked for you or if you had any issues on some specific mobile phones and which browser was used. I recommend using Google Chrome for this if possible. You can just leave a quick comment. For example, say Samsung Galaxy S22, Firefox browser, it works, or something like that. If you do that and test this game on your phone, it would help me to make the next mobile game tutorials better. We can test our code and emulate other devices in Google Chrome, but the emulation might not be 100% accurate. The only way to be absolutely sure is to run the code on an actual device. This was a big project. Well done if you managed to get all the way here. See ya!